Hey everyone, Vessel here. I wanted to add on to our literally changing data worksheet with a couple of notes here, and we're going to do that. So this was the kicker data from problem number 4, and what this process is going to do is maybe a process you've even done before, but maybe not in this particular way. So I wanted to talk about how changing data can be done in this particular context, but it's actually, this process is done in lots of other ways, or lots of other situations, I mean. So this data set has already been put into my calculator just to go through this a little bit quicker, and again, you can use other tools to calculate these things, but I've got my my list in there, and again, hit statistics, go over to calculate, number 1 and L1 is where my data is stored. So L1, no frequencies, and here we go. Here's our mean and standard deviation. Those are the two numbers that we want to work with. So let's write those down. So I think I'll use I'm going to use two decimals. I mean, it'd be great to use a few more. I'm worried that these lines down here are just kind of small, so it's might have an impact. 7.66. We're going to get a little bit of round off error. It's going to be okay. So I think I'm going to stick to the 2 decimals here. So under, we're going to use the lists, and again, if you've got a different tool, that's okay. But in the calculator, you can do this using following steps here. So hit Stat, Edit, and go over to L2. And again, I've done this before, but make sure your cursor is on L2. And what we're going to ask the calculator to do is to use L1. So push second 1, and you'll start to see it right here. L1 is what L2 is going to use to calculate, minus this 18.54, and we've got a list of deviations. So I'm going to jot these down here. So in the same order here, negative 1.54, negative 3.54, and so on. If you would like to just use 1/10 instead of 2, or instead of 100th, I could totally get on board with that. 1.6. And one more. Okay. So I got this list now, and L2, it's a whole new data set. I mean, it's based off of the yardages. Remember, these were yardages, which yard line the ball was snapped from when the kick was made. So what we just did, though, was we subtracted off the mean from all of these numbers. So we should be able to guess what's about to happen here. But I'm going to get the one variable stats. So we're going to find the mean. We're going to find the standard deviation. But I'm going to write it down. So one thing that we should have learned from this particular set of problems so far is that when you add or subtract a constant, in this case 18.54, to all the data points, it's going to change the mean by that amount. So basically what we just did was we created a data set. It's got some positive and negatives, but the mean is going to be 0. So I'm just going to write it in right now. And the other thing that is going to happen, the spread, I want to look at standard deviation. So if I sort of think about like this list, and this number represents an average deviation from the mean. So the mean's 18.54. These are in yards. Standard deviation 7.66 yards. So what we just did was we just subtracted 18 and almost 18.54 yards from each number. I didn't change spread at all. So one of the a real quick check. If we look for a couple of key numbers here, this one's the min, and the maximum is over here at 35. So just as a little bonus here, the range is 32. Maximum minus minimum. What's the range down here? Well, if I took away 18.54 from every data set, it's still going to be 32. This 35 transferred, this is that data point right there, the 16.46. So that's the maximum of this data set. But then the fourth number in, this negative 15.54, that's the minimum. That's still the minimum here. They have the same distance away. They're still 32 yards. So the mean is going to change, but the standard deviation is not going to change. And I'll show you, but this number is still going to stay at 7.66. So how I can sort of confirm that, again, I have a little bit of round off error. You know, the mean wasn't exactly 18.54. So I'm going to see, you know, a mean that's close to 0. Whoops, sorry. Let's go to second stat to calculate one variable L2. And, you know, there's the round off error there. So I have negative 0.0015. This is supposed to be 0. And then down here, notice the spread. Again, a little bit of round off error, but it's the same number to the 100th place. So 7.66 is the standard deviation still. So the next step we're going to try here is we're going to take this 7.66 and we're just going to divide that out. So we're going to divide each of these numbers, the deviations, by the 7.66. So I'll do that in L3. And I don't know if I didn't mention it. So I used YI for yardages, Y1, Y2, and so on. That's this list. DYI represents, you know, D for Y1. That's the deviation for the first yardage number. Down here we use Z. So this is Z for Y1 and so on. So the letter was not a random choice. But in L3, I'm going to take L2 and divide it by 7.66. Yeah, a little bit of round off error, but it should be okay here. So, well, I just made all my numbers a little bit smaller, didn't I? So I'm going to jot these ones down. You know, when I write these down, I'm just going to write one decimal here. So negative 0.2, negative 0.5, negative 0.1, and so on, 2.0. 2. Good place to fast forward this, which many of you already have. 1.1. Okay, so I got my list here. Still got 13 numbers in there, and now I'm going to get the mean and standard deviation of this list. Well, what happened was we just took the original list up here and divided it by 7.66. So what happens is my mean, or any specific statistic, like mean, median, Q1, something like that, is going to be decreased by a divisor of 7.66. So if you can just think about, well, the mean was 0, and I divided everything by 7.66, the mean is still going to be 0. And you can sort of get a nice visual. This is going to add up to about 0, but I've just made everything a little bit smaller. So what that changes was spread. Now remember those same 2 points that had the min and the max. Well, now the minimum is -2, the maximum is 2.1, so my spread is, or my range, is way, way lower now. Now it's just a 4.1 spread. So my average deviation is much lower, and it turns out, if I multiply or divide, I'm changing the spread by that factor. So if I had a spread of 7.66, and I just divided all of my numbers by 7.66, you could just divide those two numbers, and the answer to the division of 7.66 divided by 7.66 is 1. So my new standard deviation is going to be 1. And I'll show you in the list. We're going to use L3 here, but a little bit of round off here. It's going to be very close to the number 1. Stat, calculate L3 this time, and the mean. Oh, this is even smaller. So you see this -2. This is a really common thing that students run into, and they don't know how to handle it sometimes. E-4 is scientific notation for times 10 to the -4th, or the direct implication. This means move the decimal 4 points to the left. So this number's -0.0002. We're just going to call it 0 still. So it's 0, and it's just a scientific notation for it. So it's just a little bit above 0. And then your standard deviation, again, a little bit of round off error for sure, but 1.000. The round off there, we're just going to stick it with 1. And if I didn't use any round off error, it would have been 1 exactly. So what I wanted to point out here, kind of wrap this thing up, you've probably done some stuff like this before. This is actually a process that you can use. It's called calculating a z-score. And you may have done this before, but a z-score in general is found by taking a data point, subtracting off the mean, and then dividing by a standard deviation. And usually we don't go through the whole process of doing this step by step like that. If I want a z-score, I can just do this in one step. Take the mean away from my data point and just divide that by the standard deviation, and I get that value. So usually we just do a direct computation, but that process and I think it relates to this changing data worksheet a lot. So, I have a feeling you've worked with z-scores, but maybe not in in a more holistic approach. So hopefully this is helpful information. We'll use z-scores a lot moving forward. So something that I thought would be a good link between using z-scores like you might have before and where you are now. So thanks for checking this video out. Hopefully this is helpful information, and we'll use this moving forward. Thank you.